These are selected problems from the hard book, page 277, the Chapter 5 test. So typically when you have the Chapter 5 test from the textbook, you're going to have a test tomorrow. So let's try seeing if we can figure out how to do these problems. So the first one here says, we're doing number 3, says Stan found 12 pennies, 15 nickels, 7 dimes, 5 quarters. Tell whether the ratio of pennies to quarters or the ratio of nickels to dimes is greater. So pennies to quarters. So what that means is we need to put pennies on top, and we're going to have quarters on the bottom of our fraction. That's what this represents. So let's go ahead and set that one up. Pennies, well, there's 12 pennies. And quarters, well, there are 5 quarters, it says. So there's one fraction. And let's set up the next one. So the next one is nickels to dimes. So nickels is going on top, dimes on the bottom of the fraction. So nickels, there's 15 nickels, and there are 7 dimes. So if we want to compare these two fractions to find out which is greater, what I'm going to do is come up with that common denominator and see which one has the bigger numerator afterwards. So what I'm going to do is take these two ratios, the 12 to 5, and then also I'm going to take the 15 to the 7 and figure out what number I need to multiply each by. Now, if I look at it, there's no common factors between 5 and 7, so I'm just going to multiply this fraction, the 12 fifths, by 7 over 7. And what that gives me is 7 times by 12 gives me 84, so this equals 84, and then down below that makes 35. So I can compare it to this one if I do the same sort of thing. So I'm going to multiply this one by 5 fifths. And so when I do that, I go ahead and multiply across. 5 times 5 is 25, and I carry a 2. 5 times 1 is 5, plus 2 is 7, so 75 35ths. So now I can compare them. Now when I look at them, I'm looking at the numerators. So 84 35ths, and I had 75 35ths. So the bigger number is the one with the bigger numerator, as long as the denominators are the same. So the 84 35ths went with 12 over 5, which was the pennies to quarters. So the pennies to quarters had the greater ratio. Well, the next one is similar. We're asked to find out which is the lowest price this time. And they're going to give us some, looks like the store sells $5 or 5 pounds per box of detergent for $5.25, and 10-pound box of detergent for $9.75. So which is the better deal? Which is the lower price? So I want to know price per pound. So price needs to go on top of the fraction, and pounds, LB for pounds, on the bottom. So let's set that up. So price for this first one is $5.25. So that goes on top. And then the 5 pounds goes on the bottom. So what I want to do is I want to change it so it's just a dollar amount for 1 pound. Per means divide. That's this fraction bar here. So what I'm going to do is I'm going to reduce the fraction by dividing by 5. So off to the side, I'm going to do 5 into 5.25. So I go ahead and do the work. 5 goes into 5 one time with nothing left over. So I bring that decimal point straight up, bring the 2 down. 5 does not go into 2, but it does go into 25. It goes in 5 times. So there it is, $1.05 per pound. So $1.05 for 1 pound. Well, let's figure out the next one, see what its price is per pound. So that one is $9.75 for 10 pounds. And so we do the same sort of thing. We take out that 10, and we do that by dividing by 10. And so when we divide by 10, all we have to do is move that decimal 1 space over to the right. And I'll show you that, because again, when you divide by 10, we have 9.75. The answer is going to end up being 0.975. So let's see why. So 10 goes into 9 0 times. 10 goes into 97 9 times. It makes 90. Did the subtraction, I got 7 left over, so 75. So 10 goes into 75 7 times, makes 70. Bring the 50 or the 5 down, and 10 goes into the 50. We just have 5 times. So there's our answer. I had to bring that 0 in there. So 0.975. So we end up with 97 and a half of a penny per pound. So which is the better deal? Well, that would be the one with a bigger amount. The 10 pounds for $9.75 was the better deal. So I'll circle this one right here. So that was the $9.75 for 10 pounds was the better deal. It's less than the other. So the next set of directions ask us to find a ratio equivalent to each ratio. So the answers could vary here. So it just kind of depends on what you end up multiplying or dividing by. So the key is, and then it also says, then use the ratio to write a proportion. So we'll do that afterwards. So the key is to either multiply or divide by some number. So I'll do one way, the other. So I'll divide by 2 here because both have a common factor of 2. So when you do this, this is like dealing with 1, dividing by 1. When you divide by 1, the number doesn't change, and that's why we call it an equivalent ratio. An equivalent ratio, equivalent fraction, same thing. So we go ahead and do the work there. 22 divided by 2 gives me 11, and 30 divided by 2 gives me 15. So there it is. 11/15 is an equivalent ratio, so they wanted us to write it as a proportion. And that would be this way. 22/30 equals 11/15. So there it is. Well, next one, same sort of thing. You're just going to come up with a factor of 1, and a good factor to use is 2. This time we'll multiply by 2 over 2. So again, anytime you've got a number that is the same on the bottom as the top, it's the same thing as 1. So 1 times a number doesn't change it. So what we're coming up with is an equivalent fraction. So 10 times by 2 makes 20. 17 times by 2 makes 34. So there it is. 10/17 equals 20/34. And that is the proportion that is equal to the other fraction. So proportions are 2 fractions that equal each other. So we're going to use that concept of proportions to solve this proportion. We're going to use cross products. So this is a common term they used, and this is what we do to solve proportions. So the way we do that is we multiply the numbers diagonal from each other. So the 9 and the 6. So 9 times by 6. And we set that equal to the cross of the other products here. So 12 and m. So 12m. So we do some work there. Go ahead and multiply that 9 and 6, and we get 54 equals 12m. So from there, all we're doing is dividing, solving for m. So I'm going to go ahead and divide by 12. And 12 doesn't quite go in there evenly, but let's see how many times it does. So 12 into 54. I know 12 times 4 makes 48. And when I do that subtraction, that makes a 6 left over. And so I can write that as 4 and 6/12, or 6/12 is the same thing as 1/2. So 4 and 1/2 is another way to write that. So m equals 4 and 1/2. So there it is. So here's a problem where we can use cross products to solve an equation, a word problem. So here it is. The submarine travels 56 miles in 4 hours. Whenever you see that we can write as a fraction. And so we might end up doing that in this problem. Let's see what it says. At this rate, how many hours? Okay, how many hours? That's the question. We don't know how many hours. So we're going to use a variable to represent that. So let's use h is equal to hours. We don't know the number yet, so that's what we're going to solve for. How many hours will it take the submarine to travel 700 miles? Well, we can go 56 miles in 4 hours, So we want to know the number of hours in 700 miles. So whenever we have the same units, we can use proportions to solve this. So let's go ahead and try that. So we're going to go ahead and write a proportion this way. Miles per is that fraction bar, per hour, equals miles per hour. So when we are setting up proportions, we typically use the same units in the same location. It's not required. There's a few different ways to set it up, but this is the way I would set it up. And so we're going to start with this first fraction here, setting up the first sentence, 56 miles over 4 hours. And so 56 was miles, 4 was hours, so I set it up the proportion just like I said. Equals, now, how many hours? We don't know how many hours, so H is our unknown. Will it take the submarine to travel 700 miles? That's going to go on top of the fraction. So now we've got our proportion, so we're going to use cross products to solve. So we do this 4 times by 700, and we're going to set that equal to 56 times by h. And so we'll write that out. 56h equals 4 times 700. So we do the work there, and we now have 56h equals 2800. So I got that by 4 times 7 is 28. So now I'm going to reduce this. I'm going to go ahead and divide by 56. Now, as I do that, 56 into that number is kind of big. So I know a factor that goes into 28. 7 goes into 28. So I'm going to try reducing the fraction. And so I know 7 goes in there because I multiplied by 700. So when I do that, 7 goes into 28 400 times. So 7 goes into 28 4 times with 2 zeros. Do the same thing here. I know that I can divide 7 into 56. This is why it's important to know your multiplication tables. Because if you know multiplication tables, you know factors. Factors are numbers that you can divide into other numbers. So 8 and 400. Ooh, I know another number goes in there. Well, I know 4 goes into 400, and I know 4 goes into 8. So I can reduce this further. 4 goes into 100. Well, that's just, or 400, 100 times. 4 goes into 8 2 times. Oh, now I've got the problem a whole lot easier. I just have to divide 2 into 100, and that's a whole lot easier than trying to do 56 into 2800. So 2 goes into 100 50 times. So there it is. It's going to take 50 hours. So that's what I was solving for there. So time, 50 hours it took. Well, part 2 will have more problems on this same page.